Okay, good afternoon. Thank you all for being here, even though it's the last session of the Congress. So we're going to look at the integration of the sea cucumber Oloturia sanctori to the European abalone, Haliotis tuberculata, grow-out processes in a land-based IMTA system. So, first of all, why we started to have an interest in integrating the sea cucumber? Well, due to their interest, the interest to include deposit feeders as integrated elements of IMTA system for the consumption of organic materials, and also due to their demonstrated mitigation ability within different IMTA systems that have been tested, to optimize the net use of wastes from the different species. And this with the idea to improve the environment of the system and also improve its global management. So in order to test it, individual Oloturia sanctori were collected by scuba diving, and they were placed in experimental IMTA units of 300 liters below adult abalone. Depending on the trials, the adult abalone were fed IMTA-produced macroalgae or compound feed. In terms of the system, the abalone were placed in a compartment which was about 60 liters at a density of 50 specimens per square meter, and below the sea cucumber were placed at a stocking density of 3.75 or 2.5 specimen per square meter. And here you can see a few pictures of the experimental units, and below the sea cucumbers together with the debris from resulting from the abalone production. So we did a first trial to determine the better stocking density for the sea cucumber. So we tested two density, 2.5 and 3.75 specimens per square meter. And in that trial, the abalone were fed ova rigida and hydropunta cornea that were produced in land-based IMTA system. And there we've checked for the growth performance of the sea cucumber. And then in another trial, we've made an integrated feeding trial. And in that case, the abalone were in one treatment fed IMTA-produced macroalgae, and in that case, the abalone were weekly fed. And in the other treatment, the abalone were fed compound feed, and in that case, they were daily fed. And there we've checked the growth performance of the sea cucumber, their ingestion rate, fecal production rate, and we've also done the biochemical analysis of the debris and of the body wall of the sea cucumber. So when we looked at the stocking density, when we looked at the specific growth rate or weight gain, we've observed an inverse proportionality between sea cucumber stocking density and their growth performances. In the highest density treatment, actually the growth performance decreased, and this was linked to their ingestion rate, which was lower when the specimens were stocked at higher density and higher when they were stocked at lower density. So, as we had determined the stocking density, we then performed the other trial, stocking the sea cucumber at 2.5 specimen per square meter. And in that case, we've checked their growth performance in the two treatments. And we've observed that it was significantly higher when the abalone were fed the IMTA-produced macroalgae in comparison when they were fed the compound feed. The specific growth rate was similar to the one that has been observed for another sea cucumber, but it was clearly lower than the one that has been observed for Apoticopus japonicus. So when we looked further and we looked at the ingestion and defecation rate, we've observed that the feed source that was used to feed the abalone affected the feeding behavior of the sea cucumber. And this was not due to differences in the amount of debris that were available to the sea cucumber, as there was no significant difference in available weekly quantities of debris in both treatments for the sea cucumbers. And when we looked at the biochemistry of the debris, we've found out that there was significant difference between the compound feed treatment and the algae treatment. And there we've seen that the ingestion rate varied as a function if it was lower or higher nutritional environment they were located in. These demonstrate their ability to increase the nutrient absorption efficiency when they are placed in a high nutritional content. And it also indicates a higher digestibility of nutrients when they are subject to algal diets. And it can also indicate that extruded diets might have a deficiency of beneficial bacteria that can facilitate nutrient availability for the sea cucumbers. So when we looked at the sediment and body wall composition, in terms of biochemical composition, there was a significant difference in the biochemical composition and fatty acid profile of the debris that were available for the sea cucumber. But however, this was not reflected in the body wall of the sea cucumber, and it was also not significantly different from the one found in wild specimens. This could indicate that the sea cucumbers have the ability to adapt to nutrient absorption efficiency depending on the nutritional content of the feed they have in their environment. Looking at the fatty acid profile of the debris, globally the fatty acid composition varied significantly between treatment. And in the compound feed treatment, it was dominated by saturated fatty acid, whereas in the algae treatment, the monounsaturated fatty acids were in higher quantity. And globally, the fatty acid composition was dominated by palmitic acid, and then they generally presented low amount of PUFA, although they were higher in the macroalgae treatment. And now if we look at the fatty acid profile of the sea cucumber body wall, we observe that independently from the debris fatty acid composition, the one of the AquaVitae presented a high amount of monounsaturated fatty acid. In both treatments, they presented a similar high abundance of arachidonic and EPA, although the amounts were significantly different from the wild specimens. They were lower in the wild specimen, and as this has been reported for other sea cucumber species when they are placed in different environments. These results can indicate a PUFA synthesis capacity of the Alloteria sanctori and an ability to selectively incorporate specific fatty acid through selective feeding and ingestion of nutritious particles. Globally, when we looked at the nutritional profile, we found out that they presented high protein content, low lipid contents, and more than 50% of unsaturated fatty acid, with quite high amounts of DHA and EPA. And so, finally, we've observed that the growth performance of Alloteria sanctori was density dependent, that the ingestion rates and growth performance were significantly affected by the diet composition that they had access to. And Alloteria sanctori was able to maintain a stable biochemical composition within their body wall by adapting their feeding strategy based on the nutritional composition of the environment, and this in order to meet their nutritional needs. Generally, Alloteria sanctori presents an interesting nutritional profile with high protein content, low lipid content, and more than 50% of unsaturated fatty acid in the global fatty acid composition. And this has given us a first insight on the feasibility to integrate Alloteria sanctori to the abalone production in a land-based IMTA system. And as the Alloterias have shown high survival rates and possibilities to adapt to varieties of feed that are being supplied to the abalone. That's it. Thank you very much. Thank you. And thanks to the the AquaVitae project, part of which these experiments were performed. And if you have any questions, I'll happily answer them.
Really interesting results. I've never worked with this sea cucumber species, but for me it was super surprising that they feed better on the algae than on formulated feed. So I wanted to ask, was it surprising to you, or did you expect that they actually feed on mostly algae naturally then it seems, or and also was the formulated feed mostly, I missed that, was that also herbivorous or?
That it was surprising for us also, because we thought that with the high protein content in the compound feed, they would have fed similarly or maybe more. And actually, it was surprising. But that's where we thought about the beneficial effects of the algae and the associated bacteria that they can be associated with, and that could maybe facilitate the nutrient availability to the sea cucumbers.
Nice, thanks.
Thank you very much, that was very interesting. Maybe I missed that, but you said that the algae come from an IMTA system, but I did not see really where was the IMTA system which produces these algae.
So the system has some fish tanks which are producing sea bass and sea bream, and then they also have the abalone production tanks, and all these tanks are connected to microalgae tanks, and that's where the microalgae are being produced. So we are reusing the fish effluents and the abalone effluents to produce the microalgae, and then these microalgae that have high protein content are then used to feed the abalone.
And I asked a question about the composition of the algae. So you mentioned that they have a higher protein content than in the white. So do you have some explanation about that?
The amount of nutrients that they have available, and therefore they can maintain a higher nutritional profile throughout the year, and they don't have these seasonal peaks as marked as the one from the wild.
Okay, and you can continue with the production of this algae. I mean, you will need to have all the cycle working all the time. So what about the algae production? Do you consider that you are in the position to have always these algae produced by your IMTA system all year round?
Yes.
Or do you think that you have to stop for some?
No, they are produced throughout the year. Yes.
So you may use them for the agricultural environment.
Yeah.
Thank you.
No problem.
Thank you very much for your presentation. It was really interesting. I have a husbandry question regarding to the sea cucumber. You know that this kind of animal are normally full of water. Then their fresh body weight can be very variable. How do you do to get to measure the weight and then to calculate the growth?
Yeah, we were. So I don't know if you manipulate sea cucumbers when you take them out and then they start to reject the water that they have in their body. So they were left for like 3 to 5 minutes until they would release all the water that they had in their body, and then they were weighted after that. And we've always used the same procedures in order to weight them. But that's the way we did it. Any other?
I think that this is an arbitrary method, because not always they take off all the water. Or what? No?
Do you have a better way to do it? Because I haven't seen another way to do it. Or anybody has another way that they're doing it? I don't know. Do you have one?
Yes, but I have the same problem. This is arbitrary. We rest the sea cucumber for a time.
Yeah.
But 2 minutes, 3 minutes, 10 minutes.
We've
Because sometimes they take off a lot of water and sometimes not.
And it depends on the
used
size.
3 to 5 minutes in our case, and that's how we did it. But it's true, it can be arbitrary.
Yeah, it's going to depend on the size too. And but anyway, there is no way. And then when there is no way, we just find a method, and it's very difficult.
Yeah.
Okay, Gercende, thank you very much.
Thank you very much.
For your presentation.
Okay.